All right, so this video is going to cover 1.1 for Math 115, UMA Statistics, and this section is called Intro to Statistics. These notes are going to match the guided notes if you're choosing to use those, in case that helps you. So data can show many things depending on who is asked and what information they report out. I could ask the same group of people or three groups of people the same question and get different answers. It all depends on how things are presented. So statistics, pay attention to the capital S, is the science of collecting, organizing, summarizing, and analyzing data or information. So the whole point is that you're gathering information, you're looking at it mathematically, you're summarizing it, and then you're analyzing it to apply it to a group and share what you found in relation to an overall population. Data is that collected information. So it can be numbers, it can be words, all of that. The big thing of your statistics is depending on who you ask, you might get different answers. So you need to pay attention to where stuff comes from. With your data, you want to watch for misuse in the collection, were weird people asked, analysis reporting, are they only reporting part of it? We're going to get more into that as we go. Just understand that it's never 100% accurate because you're asking people and you're not asking everybody. The population is the group you're trying to study. So if I want to know what adult Americans think or students at University of Augusta think, that would be the population. The sample is a subset of that population, and it's the group that you're actually asking. So I'm not going to ask every American the question. I'm going to ask a sample of Americans and then apply that information that I get. At UMA, I'm not going to ask every student necessarily. I'm going to ask a group of students. That's the sample. The individual is one person in the sample. So if I ask 20 people, those people are each individuals. Okay, now we have statistic, and this should be lowercase, so I'll fix that on the actual notes. The lowercase s is a numeric summary of the sample. So after I ask people these questions, I might find the average response. That would be a statistic. I might, say like the top 3 favorite colors are and give a table and a bar graph. Those would be the statistics, the summary, the information. The parameter is when I take that numeric summary, I apply some mathematical knowledge to it, do some testing or whatever, and say, this is the numeric summary of the population. So based on my sample, I think this is the average of the whole UMA campus. So you've gone one step further and done some actual math with it, which again, we'll get into as we go. Statistics are the actual numbers you get, whereas the parameter is an estimate based on some mathematic things you've done. When you hear people talk about descriptive statistics, those are how you organize and summarize the data. Summarizing data. So this could be in a table. This could be a chart. It could be a graph. Anything that's representing the actual data you gathered from the sample. Your inferential statistics is you take inferences or you do math to extend those results to the population. For example, if I said 46% of students surveyed own a car, that's going to be a descriptive statistic because we're talking about specifically the students surveyed. If I then said, based on whatever, 48.2% of all students own a car, Now I'm saying of all students out there, whether it's UMA or whatever my population is, I used some mathematical prediction and I'm estimating that percent of all students own a car. So that's going to be a parameter or an inferential statistic, whereas this is just a statistic or descriptive. The big thing to look at is if it says of all or of surveyed. That's really going to be the easiest way to tell. All right, so statistics is a science of collecting, organizing, and data. We're looking at the math part of the science, but there's steps for how you deal with your data. So let's see, identifying the objective, that's step one. You have to figure out, what are we trying to answer? What do we want to know? In this, you want to make sure you include your population. Like, what do I want to know and what do I want to know about who? Because me asking how many students have a car is very different if I'm asking a high school student or a college student or a middle school student. So you want to put your population in there. Then you find your sample and you ask them. So you collect your data. Then you take all of your information and you summarize that and you give your descriptive statistics. So that's your overview of collected data. Then you take that and you extend to the population and you make your inferences. So extend to the population. Now, again, we'll get into those as the semester goes on, but this is just the general statements. So if we look at this sample here, this will take us into, we'll break it down. So CBS News and the New York Times conducted a poll in September 12th through 15th, 2014. And they asked, as many of you know, federal minimum wage is currently $7.25 an hour. Do you favor or oppose raising the minimum wage to $10.10? So they're trying to figure out who favors raising the minimum wage. And even though it's not said in this sentence, we're saying their population is adult Americans. So they want to know what percent of adult Americans favor raising the minimum wage. So here it says they conducted a poll. So that polling was their sample. And they asked the people, do you favor or oppose? And again, it's not said in here, but they asked 1,009 adult Americans what they thought. Now our descriptive data would be 70% favor. 706 out of the 1,009 favored raising the minimum wage. So the descriptive data would be 70% favorite. Finally, we make our inference. So using the methods, we're going to say they are 95% certain that 70% of Americans favor the minimum wage. Raising the minimum wage. With a margin of error of 3%. So that means that they think the real percent is somewhere between 67 and 73. They know it's not exact because they didn't ask everybody. So mathematically, they came up with their margin of error being 3%. So they're saying the real percent falls somewhere in this range. That's just an overview of that vocab being used. If we keep going, variables are the things we're studying. Those are the characteristics of interest. Characteristics of interest. Now, what makes it a variable is that it changes depending on who you ask. So if I ask your favorite color, different people have different favorite colors. It varies. That's what makes it a variable. And there's two ways to categorize those. Qualitative or categorical are attributes or categories. Versus Quantitative are numerical. So if I ask you your favorite color, that's going to be qualitative. If I ask you what grade you got on a test, that's numerical, so it's quantitative. So let's look at some. Gender. If I ask your gender, the answers are various responses, but they're all words, they're not numbers, so they're qualitative. If I ask the temperature, what temperature was it at noon? That's a number, so that's going to be your numerical, quantitative. If I ask the number of days that you studied this week, that's quantitative. Now, I'm going to give you a tricky one, a zip code. So, even though a zip code is a number, it's actually qualitative because the number doesn't tell you anything. The zip code tells you where you live, but it doesn't, you can't really compare the zip code like 04011 versus 04345. Like, there's no comparison to that it's no different than saying Brunswick or Gardner. Versus a temperature, you can say this is warmer or this is colder. You can't do that with zip codes. So even though they're numbers, they're really an attribute or a category. They're really qualitative data. Now we can break those down. So discrete data is countable. If you can count up your numbers or have a finite answer, that's discrete data. There's a limited number of outcomes. You can't have half a person. That's discrete. Continuous has infinite values. You can always get smaller. You can always get bigger. Any possible value. This is like a measurement. We can do feet, but then you can get into half a foot or a quarter foot or an eighth foot and keep getting smaller and smaller. Your answers are often rounded. So that's going to be the difference. So let's look at some of those. If I'm flipping a coin and I count the number of heads, that's going to be discrete. You can't get half a head. It's either heads or tails. Or maybe you're crazy lucky and it lands on the side, but it's still not half a head. It's not heads. Number of cars in the parking lot. That's discrete. If you have a car that's cut in half, you're not going to call that a car. You're not going to count that when you're counting cars. So it would be a discrete variable. Continuous might be the distance you travel or the gallons in your car, gallons of gas, because you can have on the pump 3.2 gallons. So those are continuous because they can get broken down into decimals. All right, we've done a lot of vocab. So let's review. Data, these are the values or the answers you get. Whereas the variables are the characteristics you're studying. What's important to you? What are you looking at? So if we look at this information, we asked a bunch of countries, we did a bunch of surveys, and we asked what their government type was. We looked at the life expectancy and the population. This information was all gathered somewhere. So the individuals, those are the countries. In this case, the population is the entire world. So the study was we asked the samples a bunch of countries. The individuals are the countries that we asked. So those are the individuals in this sample. Okay. Variables are what we're looking at. What do we want to know? So that's the government type. Government. That's the life expectancy and the population. Those are the questions we're asking, the things we're interested in. And then finally, the data are the answers we get. That's the information that we gather. So we have categorical data, qualitative, like the type of government. Those aren't numbers. But we also have life expectancy in years and population. So we have 3 different values in this chart, but they're all data. That's kind of a breakdown. Now, you can categorize data. There's levels of measurement. Depending on the answers, you can do different things. But you need to pay attention to what is being measured. Because again, like the zip code can be qualitative, you want to pay attention to that. So nominal data, all that does is name something. It labels or categorizes, name, label, category. You can't arrange it. Nothing's better than the other. So like a color, pink, yellow, green, blue, well, I personally can arrange it. I can't in a study say this is better than that. So it's just names. Ordinal data is still labels or categories, but you can order them. That can be ordered. So something about it can put it in order. Like first, second, third. You can put it in an order. You may not know the difference between first and second, but you know the order and how it matters. Interval, now we're getting into numerical data. So you're getting numbers that you can do something with. Interval has to do with adding and subtracting. So you can compare how many more by adding and subtracting. So that's what's important. And 0 doesn't mean none. So like you can have 0 of something. Or if we're talking about temperature, 0 degrees doesn't mean there's no temperature, just it's an actual value. And then the last one is ratio, which is also numerical. This time, the numbers are going to be compared with multiplying and dividing, and 0 does mean none. So if we're talking about rain, 0 inches of rain means we got no rain. There's no negatives in ratio because 0 is nothing, so you don't have your negatives. Okay? So let's look at some. Gender, we already said was nominal, or we already said was categorical, qualitative. And because you can't order the genders, it's going to be nominal. You just list them. Temperature, I kind of hit at this. So we know temperature's numbers, so it's either interval or ratio. But 0 doesn't mean none. 0 degrees isn't 0 temperature. It's just a value. So this one's going to be interval. You can say I'm 10 degrees warmer than yesterday. That's what that is. You can have negative temperatures, as we know in Maine. Number of days studied. So we know it's a number. But now 0 means no days. 0 means I did not study. So that's going to be ratio. Yes, you can say I studied 3 more than the other, but you can't have negative days. They don't exist. So that's going to fall under ratio because 0 means no days. Okay, letter grades, A, B, C, D, E. Well, those are in order. An A is better than a B is better than a C, but they're not numbers, so it's ordinal. Versus a number grade, wow, that was rough. A number grade can be put in order and you can tell the difference. Now, a number grade you can't have negative number grades. So your number grade is actually going to be a ratio. We're skipping that interval. 0 means none. 0 means you did no work or you got no work correct. So we're going to call that a ratio. An ID number, so like your social security number or your student ID, all that does is name you. Like when you go to the cafeteria and punch in your number or when you log in for your student ID, all it does is name you. It doesn't it's not the order you registered. It's not the order. It's the whole point is they're not supposed to be able to figure out who it is. So that's just nominal. Jersey numbers. Those are also nominal. All they do is give you a number. It doesn't mean anything. You end up with whatever number they give you. In football, the numbers, like different positions have different numbers, but you still can't put them in order. So it's just nominal. Let's see. The place you finish in a race. Well, first, second, third, fourth, that's ordinal. You put them in order. You don't know the difference. First and second could be 0.3 of a second apart. They could be 3 minutes apart. We can't compare the numbers. We just know the order. And then inches of snow would be like inches of rain. And then it's ratio because you can't have negative snow. I mean, yes, the snow melts, but that's not how we talk about it. We talk about how many inches of snow did we get. So that's how those 4 things work. That is section 1.1. Let me know if you have any questions, and good luck.